Hello and welcome to the program Sula's Big Adventures with me, Sula. In this episode, I'm going to tell you how to locate the Horsehead Nebula and how to see it with your telescope. The Horsehead Nebula, probably one of the most famous and most photographed nebulae in the night sky. Recently, there was a stunning photo of the Horsehead Nebula taken by the Euclid Space Telescope, released by the European Space Agency. But how many of you watching this have actually seen the Horsehead Nebula? And I don't mean a photograph. I mean seen the Horsehead Nebula with your own eyes through a telescope. Probably not many, but in this video, I'm going to show you how to find the Horsehead Nebula and how to see it with your telescope. First, let me tell you about it. The Horsehead Nebula is a dark nebula, which are clouds of dust and gas so dense that they block the light behind them. The Horsehead Nebula was discovered on photographic plates in 1888 by Scottish astronomer Wilhelmina Fleming, who was working for a fraction of the pay of her male counterparts at the Harvard College Observatory. And if you want to read an excellent book about Wilhelmina Fleming, Henrietta Swan Leavitt, Annie Jump Cannon, and other ladies who worked tirelessly studying glass plates at the Harvard College Observatory for Edward Pickering, then I highly recommend the book Glass Universe by Dava Sobel. Anyway, the Horsehead Nebula is also known as Barnard 33 or B33, and it's embedded within the faint emission nebula IC 434, which is magnitude 7.3 and 1,500 light years away. IC 434 is just below the bright star Alnitak and the easternmost star of the three stars making up Orion's belt in the constellation Orion the Hunter. It's part of the Orion Molecular Cloud Complex. IC 434 is a pretty big emission nebula at 60 by 10 arc minutes, whereas the Horsehead or dark nebula Barnard 33 is only 6 by 4 arc minutes. For comparison, the full moon is 30 arc minutes. So the Horsehead Nebula itself is pretty small. Dark nebulae such as Barnard 33 are categorized by their opacity on a scale from 1 to 6, with 1 being the most difficult dark nebula to see and 6 being the easiest. Barnard 33 has an opacity of 4, so it's hard to see, but there are harder ones. All dark nebulae are difficult to see unless you are in a truly dark sky site. Now I've told you about the Horsehead, but before I tell you how to find it, we have to prepare, and you'll need a few things in order to see it. Number one and most important, you absolutely must go to a dark sky site if you want to see the Horsehead Nebula. You're not going to see it in an urban setting, and you won't even see it in a suburban setting. You'll need to take your telescope to a truly dark sky site. Because light pollution is so prevalent that most people have never even been to a truly dark sky site, let me talk about this somewhat more. There are different ways to measure the darkness of the sky. You can measure it by looking directly at the zenith and seeing what's the faintest star you can see with your naked eye. And this is called naked eye limiting magnitude, or NELM. If you can see stars up to magnitude 8, then you're in a truly dark sky site. If you can see stars naked eye up to 6 or 6.5, then you're in a rural suburban transition zone. And if you can't see stars of even magnitude 6, then it's not dark enough where you are, and you won't see the Horsehead Nebula. But naked eye limiting magnitude depends on good eyesight, and it requires a star chart and spending a good amount of time figuring it out and craning your neck uncomfortably, and to tell the truth, I never do it. It takes too long. Another way to measure the sky darkness is the LVM, limiting visual magnitude, and with this method, you look at some stars near Polaris, as shown in this diagram, which indicates the magnitude of the various stars, and you look at those stars, and you see if you can see most, if not all, of the ones indicated in the spiral of stars connected with dots. If you cannot see all of those stars, it's not dark enough where you are, and you won't see the Horsehead Nebula. Another way is to use a device that will accurately measure the sky luminance. Unihedron makes such a device called an SQM, and it's about $162 US, and it uses a scale of magnitude per arc second squared, with 21.75 to 22 being the darkest possible sky. So using an SQM is the easiest way to determine if your sky is dark enough to see the Horsehead Nebula. You'll need a measurement of at least 21.3. If you don't want to purchase an SQM and you don't want to take the time to determine the naked eye limiting magnitude or the LVM, then a quick and easy method to determine the sky darkness is the Bortle scale, which is from 1 to 9, 9 being the most light polluted in inner city such as Las Vegas, and 1 being the darkest sky possible. Somewhere very dark and remote, such as Big Bend National Park in Texas. And you can look up where your dark sky site falls on the Bortle scale by looking at your coordinates on an application, Zasteria, for example, or you can find a dark sky site by consulting lightpollutionmap.info. Since most of you watching this live in Bortle 4 to 9, because by definition most people live in urban or suburban areas, which is not dark enough, I would recommend finding a nearby dark sky site by consulting the light pollution map or looking up nearby certified dark sky sites, if any, near you, or just look for somewhere dark nearby, like a national park or a country road or just somewhere very remote and away from city lights. Now that you know how to assess your site, you're probably realizing now that your backyard is not dark enough. And if you want to see the Horsehead Nebula, you will need to take your telescope to another location that you have to research for and find. If that sounds like too much work, then you're not going to see the Horsehead Nebula. It's that simple. So, the number one thing you need is a truly dark sky site, meaning at least Bortle 3, naked eye limiting magnitude 6.5, and SQM of 21.3 or better. Number 2, you must dark adapt your eyes. Your pupil will dilate to its maximum extent after just a few minutes of going outside at night. But then a chemical process will take place, allowing your eye to reach its maximum dark adaptation. And this takes several hours. According to Steve Waldee, who conducted a Horsehead project to determine what's necessary to see the Horsehead Nebula, you need to dark adapt on the day you plan to observe the Horsehead Nebula for 3 hours. I think that's very difficult to do. And I'm sorry, Steve, but maybe a little excessive. In my humble opinion, I believe an hour should be adequate. But I recommend that you get one of these eye patches to wear over your dominant eye, the one you observe with, and wear the eye patch like this for an hour before looking at anything. Do not look at your phone. Do not look at Jupiter. Do not look at Venus. Do not look at anything bright. Do not look at any lights. Do not look at any stars or anything at all until you're ready to observe the Horsehead Nebula. The next item you need in order to prepare is a good star chart. In Sky and Telescope Pocket Atlas, there is a chart for IC 434 on page 14, but it's too small. So go to the back where they have the enlarged maps on page B and study that. What I did was I made a mirror image of this page because in a refractor or a Schmidt-Cassegrain telescope, you'll see a mirror image. And I can use that with a Schmidt-Cassegrain or a refractor to make sure I'm looking in the right place. For a Dobsonian or other Newtonian reflector, I made an inverted image of this page because that's what you see in a reflector. I'm going to be using a Dobsonian first, and then maybe a Schmidt-Cassegrain, maybe a refractor too. And that gets me to the next issue, which is what size telescope do you need to see the Horsehead Nebula? Well, I've heard of people seeing the Horsehead Nebula in small telescopes and even binoculars. But if this is your first time, you can forget about that. If you followed my advice and you found a truly dark sky sight, Bortle 1 or 2, no worse than Bortle 3, and you dark adapted your eye for at least an hour or more, and you know exactly where to look, then you could get by with a 100 to 150 millimeter telescope that's 4 to 6 inches to see Barnard 33. This is according to some well-respected amateur astronomers such as Alan Dyer and Paul Gray. Now you'll need just one more thing, and it is essential, and that's a good quality H-beta filter. If you want to know more about Nebula filters, you can watch my video on filters, and I'll give you the link to that here and in the description below. I'm going to be using a Lumicon H-beta filter, but there are others. Just make sure that it's a high quality one. And you can also try a UHC filter. You can start with the UHC filter and see how that goes, and then try the H-beta filter. Okay, so those are the things you need. A truly dark sky sight, your detailed star chart, your eye patch, your UHC, and your H-beta filters, your telescope, and make sure it's well collimated and cooled down. And since it's winter time, well, in the northern hemisphere, and most likely cold, wear lots of clothes. And now we're ready to find the Horsehead Nebula. To find it is pretty easy. You just go to the constellation Orion the Hunter, and you find his belt, and you go to Alnitak, the easternmost star in his belt, and then you just go south a little bit from Alnitak. But before that, you should try to see if you can see the emission nebula NGC 2024. It's just northeast a little bit from Alnitak, but be sure to block out Alnitak or get it out of the field of view, because the light from Alnitak will surely make seeing NGC 2024 or IC 434 or B33 impossible. Now let's talk about what eyepiece to use. In a recent episode, I went over the exit pupil, and I'll provide a link to that, and how using the best exit pupil will make the most of your telescope and help you see faint deep sky objects and see the brightest image. If you were able to download Steve Waldy's eyepiece software, it'll tell you the best exit pupil for the Horsehead and a lot of other objects for your particular telescope whose parameters you have to enter. I used Steve Waldy's eyepiece software, and I entered the parameters for my 10-inch Dobsonian with a 24mm eyepiece, and even though Steve told me that 5mm exit pupil was the sweet spot, according to his software eyepiece, my chances of seeing the Horsehead Nebula with my 10-inch Dobsonian and a 24mm eyepiece in my rural setting in Montana will only result in a marginal chance of seeing it. I'm not sure why eyepiece says my chances are marginal, but I'm going to try with my Dobsonian anyway. And Steve encouraged me to do so. You can also enter the parameters of your telescope and the object into his software or the Royal Astronomical Society of Canada's contrast software, and they'll both tell you if your combination of telescope and eyepiece will result in your being able to see the object. So you can use Steve's eyepiece software or the contrast calculator or some other calculator to determine what eyepiece to use to get a 5mm exit pupil, or find out if your combination of telescope and eyepiece and filter will result in your being able to see the Horsehead Nebula. For my 10-inch Dobsonian, which has a focal ratio of 4.7, that means using a 24mm eyepiece that will give me 50 times magnification and a 5mm exit pupil. And that seems about right to me. Now that we've gotten all the requirements out of the way, we'll go outside and we'll see what happens. I'm going to use my red light. My white camera light will be too bright and ruin my dark adaptation, and I'll probably even turn off the red light. Okay, here's Orion, and the lowest star of his belt is Alnitak, and that star to the right of Alnitak is Sigma Orionis, and then just below Alnitak is where we'll be looking for the Horsehead Nebula and IC 434. Welcome back to the program. I'm out here with my 10-inch Dobsonian. That's 254 millimeters. It has a 1200 millimeter focal length. It's f4.7. I've been out here for 2 hours, by the way. I started with a 24 millimeter eyepiece. That gave me 50 times magnification. I looked at IC 434 with no filter. Then I used a UHC filter. And then I put in the H-beta filter. I have a Lumicon H-beta filter that I used. And IC 434 was very obvious. And by the way, I don't know why people say to start by looking at NGC 2024. I wouldn't do that. There's no way to block Alnitak, and Alnitak is very bright. I would say instead just keep trying to see IC 434. So IC 434 was very obvious with the H-beta filter, and I had to look a long time. I couldn't really see the horse's head. It looked more like a whole horse. It was jumping all over the place. So I went and got a 16 millimeter eyepiece. That gave me 75 times magnification, I think, and an exit pupil of 3.4. I'm sorry if my math is wrong. And then I could see the horse's head. So I have trod on the untrespassed sanctity of space and touched the face of God. I saw the Horsehead Nebula with my 10-inch Dobsonian telescope. I did use the 5 millimeter exit pupil, but I couldn't really see it. I mean, it just looked like there were dark holes everywhere. But when I put the 16 millimeter in with the H-beta filter, then I could see the horse's head. That was a 3 millimeter exit pupil, so yes, I could see the Horsehead Nebula with my 10-inch Dobsonian. 2 other things I would highly recommend, in addition to the other things I mentioned: a blanket, not just because it's freezing out here, but to put over your head and block out any extraneous light. Secondly, a chair, because you need to look at it for a while. And I had to use averted vision. I had to just keep looking at it and use averted vision, and then finally it became apparent. And good luck if you try for it. Definitely go to a dark sky site. I would say the transparency here is 5 out of 7. I forgot my sky quality meter, so I can't take a reading, but according to Zasteria, it's a Bortle 3, and I looked at the stars and the Little Dipper, and I could see most of them. So I am giving it 5 out of 7 transparency. So I will draw a sketch of what it looked like with the 16 millimeter eyepiece and my 10-inch Dobsonian. Hello again. I was going to try to also see the Horsehead Nebula with a smaller telescope, my 6-inch refractor, but it's very cold. And since it took me 2 hours to see it with my 10-inch Dobsonian, I think I would die of hypothermia before I would be able to find it with the 6-inch refractor. So instead, I decided to try to see it with the 12-inch Schmidt Cassegrain. I saw it in February, but it was a very unsatisfying look. So this time I spent a lot more time dark adapting my eyes, and so I started with this 56 millimeter eyepiece from Astromania that I actually really like. I like how it looks, but I realized that it's the only 2-inch eyepiece I own, and I don't own any 2-inch Nebula filters, so I had to switch to something else. Oh, I saw NGC 2024 easily with this 56mm eyepiece without even a filter. So I went back to my standard eyepiece, my 36mm eyepiece that gives me 86 times magnification and a 3.6mm exit pupil. And then I went to IC 434 and I could see it. I started with the UHC filter. I could see IC 434 very well with the H beta filter. And then I spent a long time looking and looking, and then finally I saw the notch. It did not look like a horse's head to me. It just looked like a dark notch below the 2 stars that are on both edges of IC 434. But I saw the Horsehead Nebula in the 12-inch Schmidt-Cassegrain and the 10-inch Dobsonian. And I will show you my sketch of how it looked in the Schmidt-Cassegrain, but don't expect anything professional because it's cold out here. I don't know how people sketch when it's this cold. But that's it for this presentation on how to locate and see the Horsehead Nebula. I hope you enjoyed it, and I hope you can find the Horsehead Nebula and see it in your telescope. I'll see y'all soon. Dark skies forever. Sula signing off.